Before we plunge into the declaration, understanding what is significant is essential. Molecule gas pedals, such as the enormous Hadron Collider, LHC, worked by CERN, represent monumental scientific achievement. The LHC is a 17-mile ring of superconducting magnets and the world's largest and most powerful atom smasher. It symbolizes the zenith of human scientific accomplishment. Truth be told, it's so powerful that it can reproduce the very states of the universe's birth. However, could this machine, designed to unlock the secrets of the universe, hold the key to something far more ominous? CERN, established in 1954, is one of the world's most renowned research organizations, with 23 member states and thousands of scientists. It serves as a hub for collaboration and innovation. The LHC is CERN's flagship project, yet it's only one part of an extensive network of accelerators and experiments. Imagine a track, not for vehicles or horses, but for subatomic particles racing against time and space. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. These collisions create temperatures millions of times hotter than the sun's core. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than outer space. The proton beams inside the LHC are designed to collide at 4 points around the accelerator ring, corresponding to the locations of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together, they act as massive cameras, capturing snapshots of these collisions. Scientists then sift through the resulting debris, searching for evidence of elusive phenomena, such as the Higgs boson, also known as the God particle, and other mysteries that provide clues to the fundamental building blocks of the universe. By studying the microcosm, we gain insights into the macrocosm. However, with every answer comes a new question, and every discovery brings new challenges. The LHC isn't just a scientific tool. It's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces shaping our universe. Yet, as we push the boundaries of what we know, we must also confront the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding inadvertently unleash forces we cannot control? In the hallowed halls of CERN, where the limits of human comprehension are continually pushed, a discovery has emerged that sends shivers down the spines of even the most seasoned scientists. Brian Cox, a former scientist at CERN and a leading voice in the field of particle physics, recently made a declaration that has left the world both fascinated and uneasy. Cox revealed that the objective of CERN's Large Hadron Collider is to reproduce a miniature Big Bang, a scaled-down version of the very event that gave birth to our universe. The implications of this goal are extraordinary, as the LHC holds the potential to unlock the mysteries of the Higgs boson and explore dark matter, a mysterious substance that constitutes a significant portion of the universe. Imagine wielding the power of creation, the ability to summon the very essence of the universe. It's a tantalizing prospect, but one fraught with risk. The miniature Big Bang is no longer a theoretical concept. It's a tangible reality within the LHC. The temperatures, pressures, and raw energy mimic the conditions of the universe's infancy. It's like standing at the dawn of time, witnessing the birth of existence itself. But with such power comes responsibility, and a question looms. What if something goes wrong? In 1978, a Russian physicist, Anatoly Bugorsky, experienced a catastrophic event that forever altered the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Russia, a malfunction caused his head to accidentally cross the path of a proton beam. The beam, with incomprehensible energy, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky witnessed a flash brighter than 1,000 suns, but felt no immediate pain. The beam's path left a trail of destruction, burning through tissue and bone. Miraculously, He survived, though he suffered hearing loss in one ear, partial facial paralysis, and other complications. Despite this, his intellectual faculties remained intact, and he continued his scientific career. This harrowing incident underscores the immense power and potential dangers of particle accelerators. The risks associated with machines like the LHC should not be underestimated. The possibility of unforeseen reactions or disruptions to the fabric of space-time is not mere science fiction, but a genuine concern among some in the scientific community. One of the most unsettling and intriguing fears surrounding the LHC's experiments is the potential to create a miniature black hole. Black holes are regions of space-time where gravity is so intense that not even light can escape. The idea that the LHC could create such an entity, even on a minute scale, is staggering. Could such a black hole grow uncontrollably, consuming the Earth from within? Scientists at CERN assure us that any black hole created would be unstable and would vanish almost immediately. Still, the mere possibility has sparked debates, fears, and a sense of awe at the power we wield. To understand how the LHC could create a black hole, consider this. When protons collide at nearly the speed of light, the energy released is so immense that it warps the fabric of space-time. In quantum physics, where the rules of the universe are both strange and beautiful, theory suggests that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could exploit them, creating a gravitational funnel that forms a microscopic black hole. Even renowned physicists like the late Stephen Hawking have pondered the implications of such experiments. In his writings, Hawking warned of scenarios where the Higgs boson could become unstable at extremely high energy levels, potentially triggering a catastrophic event known as vacuum decay, an occurrence that could destroy not just Earth, but the entire universe. The stakes are undeniably high, and the margin for error is razor-thin. While scientists at CERN argue that the energies involved are well within the range of natural cosmic phenomena, the ethical and existential questions persist. The LHC represents both the pinnacle of human ingenuity and a humbling reminder of the unknown. As we continue to explore the mysteries of the universe, we must also weigh the risks, responsibilities, and profound implications of our discoveries. The possibility of creating miniature black holes or triggering unforeseen cosmic events is not only a subject of scientific inquiry, but also one of public debate. While many scientists argue that the likelihood of catastrophic outcomes is negligible, others caution that even the smallest probability of existential risk warrants serious consideration. After all, the forces and energies being manipulated by the Large Hadron Collider, LHC, are unprecedented in human history. To put this into perspective, the energy density achieved during LHC collisions mimics the state of the universe mere fractions of a second after the Big Bang. This level of energy could, in theory, open doors to phenomena that are currently beyond our understanding. Whether it's the creation of short-lived black holes, portals to extra dimensions, or other anomalies that defy conventional physics. The legacy of experimentation. Humanity's history is filled with monumental experiments that changed our understanding of the universe. From Galileo's telescope to the Manhattan Project, each step forward has come with its own risks and ethical dilemmas. The LHC is no different. What makes the LHC unique is the scale of its ambition. Its goal is nothing less than to uncover the deepest secrets of the universe. What is dark matter, and why does it account for most of the universe's mass? Are there hidden dimensions that could explain the peculiarities of quantum mechanics? What is the ultimate fate of the universe? These questions have profound implications, not only for physics, but for philosophy, theology, and our understanding of existence itself. The potential to answer such questions is exhilarating, but the tools we use to probe these mysteries are not without risks. The ethics of discovery. As we strive to unlock the universe's secrets, we must also grapple with the ethical implications of our actions. What responsibility do we bear if our experiments inadvertently cause harm on a global or even cosmic scale? This isn't merely a hypothetical concern. Martin Rees, the British astrophysicist, has pointed out that the probability of catastrophic outcomes from particle physics experiments may be low, but the consequences, should they occur, would be unimaginably severe. Moreover, some critics argue that experiments like those conducted at the LHC could lead to unforeseen consequences, not because of a lack of scientific rigor, but because the universe itself is inherently unpredictable. The very act of pushing the boundaries of knowledge often means venturing into uncharted territory, where the rules as we know them may no longer apply. Balancing curiosity and caution. At its core, the debate over the LHC and similar experiments boils down to a balance between scientific curiosity and existential caution. On one hand, the potential discoveries from the LHC could revolutionize our understanding of reality, paving the way for technological and intellectual breakthroughs that are currently unimaginable. On the other hand, the risks, however small, remind us that science is not without consequences. The LHC itself is a testament to human ingenuity and ambition. It is a symbol of what we can achieve when nations and scientists collaborate toward a common goal. Yet, it also serves as a sobering reminder of the responsibility that comes with such power. The future of high-energy physics. As the LHC continues to operate in newer, more powerful particle accelerators are proposed, the questions of safety, ethics, and public accountability will only grow more urgent. Projects such as the proposed Future Circular Collider, FCC, which would dwarf the LHC in size and power, raise the stakes even higher. Will these machines bring us closer to understanding the fundamental nature of reality? Or will they push us beyond the point where we can safely navigate the consequences of our discoveries? A final thought. The Large Hadron Collider is more than a scientific instrument. It is a mirror reflecting both the incredible potential and the inherent risks of human ambition. As we stand on the precipice of discovery, we must ensure that our quest for knowledge does not come at the expense of our own existence. The universe is vast, mysterious, and awe-inspiring, but it is also fragile. In the words of Carl Sagan, we are a way for the cosmos to know itself. Let us ensure that in seeking to understand the cosmos, we do not lose sight of the responsibility that comes with that knowledge. Entry to another universe or aspect. This idea, however, to a great extent excused by mainstream researchers, has caught the creative mind of many and has turned into a subject of interest, dread, and even fables. What lies beyond our existence? Might we, at any point, unintentionally release powers or elements that we don't comprehend? The thought of opening an entryway to damnation has indeed even been sensationalized in various media, stoking the fire of vulnerability. Yet how did this thought come to be, and what does it mean in the context of logical investigation? The idea of equal aspects isn't new in material science. String theory, a main possibility for a unified theory of everything, posits that there might be more than the recognizable three components of space and one of time. These extra aspects could be compactified or stowed away from our insight. However, they could hypothetically be gotten to or uncovered under extreme circumstances. Now imagine the LHC as an infinite key opening doors that have been sealed since the earliest days of recorded history. When protons crash at energies never before achieved on Earth, they could in principle make waves or vibrations that test these secret aspects. It is the stuff of science fiction, but it has a basis in the mathematics of string theory. Could we unwittingly open a door to another world? Or worse, release something we have no control over? So, what does this all mean for humankind's future? Should we end our quest for knowledge for fear of the unknown? Or should we press forward, embracing that the pursuit of revelation is both an honor and an obligation? The questions raised by the LHC's investigations are vast and significant, and the answers will continue to shape how we might interpret the universe and our place within it. One thing is certain. The LHC has the potential to change all that we know about the universe and our very existence. Yet with that knowledge comes an unnerving acknowledgement. There are some things that are best left unseen. As the LHC continues to stretch the boundaries of how we might interpret the universe, its very existence serves as a reminder of the double-edged nature of human curiosity. While the quest for knowledge and discovery is respectable The questions surrounding particle accelerators like the LHC challenge us to re-examine the balance between scientific progress and the potential risks involved. The excitement around the LHC is not just about unraveling the mysteries of the universe, but also about confronting the deepest fears of what could go wrong. One of the central questions raised by CERN's investigations is whether humankind is ready to handle the consequences of these discoveries. The LHC's primary objective, to open the secrets of the universe, depends heavily on exploring quantum physics, a field that challenges intuition. As we endeavor to understand the very forces that govern existence, researchers are increasingly finding that the rules of classical physics no longer apply at the quantum level. This strange world of subatomic particles works according to probabilities rather than certainties, making predictions difficult and adding to the inherent dangers. In fact, one of the most intriguing results of the LHC's research has been its investigation into quantum fluctuations. These tiny, seemingly insignificant disturbances in the vacuum of space can lead to phenomena that have, until recently, never been observed. One such concept that has come to the forefront is the possibility of quantum tunneling, where particles can move through barriers that, according to classical physics, they should never be able to cross. In a way, this mirrors the uncertainty and unpredictability surrounding the work being done at CERN. It serves as a reminder that, while we can observe and measure these minuscule particles with staggering accuracy, the results may still be governed by forces we don't fully understand. However, as disturbing as the risks may seem, the allure of discovery and the potential to answer questions that have lingered for centuries cannot be denied. The study of dark matter, for example, could revolutionize our understanding of the universe. Dark matter makes up about 85% of the universe's mass, yet it remains invisible and undetectable by current instruments. The LHC's experiments, with their ability to manipulate particle collisions at extremely high energies, could offer the breakthrough that physicists have been waiting for, possibly providing the first definitive evidence of this elusive substance. Still, there are those who believe that the drive for discovery may be clouding our judgment. Critics of the LHC often point out that, while the potential benefits are exciting, the risks could be catastrophic. One of the most unsettling aspects of the LHC is its ability to create conditions similar to those that existed in the moments following the Big Bang. If a miniature black hole were to form, it could cause strange and unpredictable results. While scientists insist that such a black hole would dissipate within nanoseconds, some argue that we cannot be so sure. The idea that we could replicate the extreme conditions of the early universe carries a heavy responsibility, and some fear that humankind's ability to control this power is still very limited. The LHC's ability to create potentially supernatural phenomena isn't just confined to black holes. In theoretical physics, there is a concept known as the multiverse, that there may be an infinite number of parallel universes, each with its own unique properties. Some have hypothesized that the experiments at CERN could give us a brief glimpse into these alternate universes. While this remains highly theoretical, it highlights the broader implications of the work being done at the LHC. What if we could somehow interact with, or even control, these alternate realities? The very thought sends a shiver through both established scientists and the general public. Furthermore, there is a broader ethical question that arises from all of this. Should humankind attempt to push the limits of scientific understanding without fully knowing the consequences? Just as with any powerful resource, there is the possibility of abuse, whether intentional or accidental. Throughout history, humankind has made discoveries that were once thought impossible, from nuclear power to genetic engineering. While these discoveries have led to astounding advances in medicine, technology, and energy, they have also had potentially negative side effects, some of which have been catastrophic. In this light, the work at CERN may be a harbinger of both the promise and danger that comes with scientific progress. It asks us to consider whether the pursuit of knowledge, no matter how noble, is always worth the potential costs. The LHC represents not only a monumental challenge in particle physics, but also a metaphor for the broader human quest to understand our place in the universe. As we push the boundaries of scientific inquiry, we face a crucial crossroads in our understanding of the universe. The work being done at CERN is not just about unlocking the mysteries of the cosmos, but also about confronting the inherent risks that come with such power. The very nature of the LHC's experiments challenges us to grapple with the ethical implications of discovery and the potential consequences of unintended results. What if we unlock secrets that we are not yet equipped to handle? The very idea that we could be opening doors to realms beyond our comprehension is both exhilarating and terrifying. We must ask ourselves, are we ready to take on the responsibility of such knowledge? Are we prepared to face the unknown consequences of our actions? The LHC, in its quest to reveal the fundamental nature of reality, serves as a reminder that scientific progress is not a linear path. It is fraught with uncertainties, unknowns, and ethical dilemmas. While the potential for groundbreaking discoveries is immense, the risks are not to be taken lightly. As we continue to explore the deepest questions about existence, we must balance our thirst for knowledge with a cautious awareness of the dangers that may lie ahead. In the end, the pursuit of knowledge is a fundamental part of human nature. It is what drives us to explore the unknown, to question the boundaries of what we understand, and to reach for greater truths. Yet, this pursuit must be tempered with responsibility, humility, and a recognition of the profound impact our discoveries may have, not just on ourselves, but on the future of humanity and the world we inhabit. The work at CERN and the questions it raises ultimately remind us that the universe is a vast, mysterious place. There is much we do not yet know, and much that may be beyond our current understanding. But with every new discovery, we inch closer to understanding our place in the grand tapestry of existence. And as we continue on this journey, we must be ever mindful of the delicate balance between the pursuit of knowledge and the potential dangers that accompany it.